Welcome to Mickey Study Circle channel. In this video, we shall see how to do the computer drafting of the orthographic projection of planes using the Solid Edge software. Coming to the problem statement. Draw the projections of a circular lamina of 50 mm diameter, which is standing with one of its points on the rim on HP, and the lamina is inclined at 45 degrees to HP. The diameter at right angles to the diameter which is passing through the point on which the lamina rests is parallel to VP. Draw the projections of the lamina. So, looking at the problem statement, we can arrive at a set of conclusions. First one, the type of polygon or the plane that we have got here is circular lamina, which is having a diameter of 50 mm. And the resting condition is it is standing with one of its points on the rim on HP. So we need to consider one particular point on the rim of this particular circular lamina. Here, the rim, nothing but the circumference of the circle, and the lamina is inclined at 45 degrees to the HP, and also the diameter at the right angles to the diameter which is passing through the point on which it is resting is parallel to VP. Draw the projections of the lamina. So now we shall begin to construct the solution for the problem by drawing the XY line. So let us draw an XY line of thickness 0.18 mm of any arbitrary length and annotate the line as XY. Also annotate the reference planes as VP and HP. So as per the initial condition statement given in the problem, we have got a circle which is resting on HP on one of its point on the rim of the circle. So the top view of the circle is going to be this, but here we need to mention the diameter of the circle which is equal to 50 mm. So the radii is given and the diameter is also given in the options here. So the one which is highlighted is the radii. So I'll enter the radii as 50 mm. And we have got a circle which is having a radii of 25 mm and the diameter of 50 mm. So I can just show the diameter of the circle to be 50 mm. So since in most of the polygons we used to have the sharp corners, and drawing the projection lines from each of the sharp corner to get the front view was easy. But however, here we do not have any sharp corner, but it is a smooth curve which is passing about a fixed point. So in order to get the fixed points on this circumference, we shall draw the vertical and the horizontal diameters first, and then later on divide the circle into 8 equal parts so that we get 8 unique points on the circumference of the circle, which is helpful for us to represent the front view and the other corresponding views of this particular circular plane on the VP end as well as HP. So for that, let us consider the line of thickness 0.13 mm. So all these diameters are the imaginary entities. So we shall draw them using the thin lines and not the thick lines. So these are the horizontal and vertical diameters. And now we shall divide this circle into uh, 8 equal parts. So now it has been divided into 4 parts, 1, 2, 3, 4. So now we shall divide each of this sector into 2 halves. So we shall draw a line of 25 mm measuring 45 degrees. Similarly, here we shall draw the line of length 25 mm, but the angle shall be 45 degrees. So now we will use the extend to next option and extend this diameters at the 45 degrees angle. So now we have got totally 8 points and we will annotate those 8 points. So we'll start from here. So towards the right hand side of the circle of the observer, we are going to have the resting point, that is A. So this is the point on the rim of the circle. So this is A and this is B, this is C, this point is D, and this point is E, this point is F, and this is G followed by H. So now we shall draw the front view of this. So in order to get the front view of the circular plane, let us try to draw the projection lines from each of the points that we have drawn. So from B passing through H, intersect the XY line. Similarly, C and G, we already have got the diameter and intersect that to the xy line. Similarly, from point D through the point F, intersect the xy line, and from point E, intersect the xy line. So now we will get the front view of the circular plane by trimming this portion of the xy line and joining the endpoint of each projectors with a thick line of thickness 0.50 mm. So from the endpoint of this to the projector endpoint, so connect all the endpoints of the projectors to get the front view of the circular lamina. So now we will annotate the front view. So this is A dash, and the observer is going to look in this direction. So first the point B dash is visible, H dash is not visible, so inside the bracket. And similarly here, C dash is visible first and G dash is not visible, so inside the bracket, followed by D dash and F dash inside the bracket. And next E dash, which is visible. So we'll just try to arrange the annotations along the corresponding points. Always ensure that all these are the intermittent lines and not a continuous line marking the front view of the circular plane. So now this completes the first condition that is given to us, which tells that a circle is resting on the HP on one of its points on the rim. Okay. So now he tells that this particular plane is inclined to the horizontal plane at an angle of 45 degrees to the HP. So for that, what we will do is we shall select the front view of the circle plane along with the annotations. And then move this front view of the line towards the right hand side of the XY line by ensuring the copy option is on. So now we will rotate this circular plane with respect to the HP at an angle of 45 degrees. Ensure the copy is off. So it is with respect to the horizontal plane. So we are going to get the front view on the vertical plane like this, which is going to appear as a straight line. So the angle of inclination, you can just show this. So now we shall draw the vertical projector downwards and complete the top view of the circle when it is inclined to the HP at an angle of 45 degrees. So choose the projection lines of thickness 0.13 to draw the projection lines. So from each of the endpoint, draw the projection lines and ensure all the projection lines shall be having an angle of minus 90 degrees. So totally we have got 5 projection lines, and we shall draw the horizontal projection lines now. So from point A, intersect the projection from point A. Similarly, from D through B, intersect the projection lines of B and H. Similarly, from C and from E to A, it is already done. So F to H, so intersect this, and from point G, intersect the projection from G. So we have got these points. So now in order to complete the top view of the circle, so we know that it is going to appear as an ellipse. So what we can select is, we can select the ellipse by 3 points. In the circle by center point drop down menu, we can select the ellipse by 3 point option and choose the minor and the major diameter of the ellipse to complete the ellipse. So first point is this, second point is this. Okay, so we'll first select this point, and this is the second point, followed by the third point. So this entire ellipse is visible, so it is having a thickness of 0.50 mm. So now we can just trim the lines of the projection which is not required to us. So with this, we complete the top view of the circle when it is inclined to HP at an angle of 45 degrees. So we will annotate the points. So this is point A, point B, point C. So these are all the points on the circumference of the circle. We shall not call them as the corner points, but they are simply the points which are lying on the circumference of the circle. Okay. So now this completes the second position of the lamina. So with respect to the VP, he tells that the diameter perpendicular to the diameter which is passing through the point on which it is resting. So it is resting on the point A, and through that the diameter passing is E, and the diameter perpendicular to this diameter AE is GC. So this GC is held parallel to the VP. So this is what is the given condition. So for that, let us just select this entire ellipse and make this a rigid set. Tell accept. So since the projection lines are also coinciding, it will not take the option. So for that, for time being, we'll just disconnect the ellipse from all the projection lines to make it rigid, and then we can use the extend to next option. So now we will select the ellipse and make it a rigid set. Till accept. So now it is a rigid set. So use the extend to next option and then continue the projection lines. Okay. So now we shall select the circle. So here, okay. So keeping the control key, select the ellipse and then the annotations, and also this inner rectangle. So you can just see that all this is getting selected as a single entity. So for that, we shall use the trim option first and have the inner rectangle as it is. We'll just try to disconnect the ellipse from all the projection lines so that it is moved along with the rectangle that is there inside. So AE is the diameter, the minor diameter, and GC is the major diameter of the ellipse. So select all this and then ensure you're going to move the object keeping the copy on. So now the point G shall be kept as a reference and it shall be moved. Okay. So now just connect all the projection lines. You can also use the split command without deleting the entire projection lines, so that maybe we can see it in the next problem. So now we'll select this entire ellipse and select the rotate option, keeping the copy off. So as per the problem statement, this diameter, that is GC, must be made parallel to the VP. So with this option, so keeping the first point, that is G, and next C, I'm going to rotate in such a way that it is being parallel. So you can see the angle of rotation as 90 degrees. And we also know this, it is resting on one of its point A. So the point A must also touch the VP. So with this concept in mind, we shall ensure that the point A is going to touch the VP. So since it is the top view, ensure all the points are within the HP only. So now we shall draw the front view of this lamina. So select the line option and draw the projection lines from each of the points. So similarly from C, the corner, the point C is here. Okay, so now you can use the extend to next option. From DB, extend until it is going to meet the projection from D. And similarly, this is AE. So A is on the XY line, but E is here. So extend this till here. And similarly, this is the point. Okay. So now we shall go for curve option. So the point A is here. So get the point of intersection, followed by the point B. Point C is here, followed by D, end point E, and then okay. So we haven't taken the projection from G yet, so it has to go for G. So we will just undo this and draw the projections from G. So now let us select the curve option. Ensure the thickness of the curve is 0.50. So we'll start from point A, followed by point B, C, D, E. Okay, F should be here actually. So we'll just consider this as F. This is G, and the point of intersection is H, and from H to A. So with this, we complete the top the front view of the circular lamina. Okay, so let us mark the point H here, which was missing. So we'll just extend this to get the point F. So now we'll do the annotation. So this is A dash, and this point of intersection is B dash, and this is C dash, this is D dash. So in the manual construction, we follow the smooth curve method to draw the smooth curves of this front and the top views in the second and the third position, but here we use the curve option. And this is the point H. So with this, we complete the problem statement. So now let us use the trim option to trim the projection lines of unnecessary length. Okay, so to sum up, we have got a circular lamina resting on HP on one of its point on the rim, that is point A. So rim is nothing but the circumference. And the diameter of the circular lamina is measuring 50 mm. So first we draw a circle of diameter 50 mm, divide that into 8 equal parts so that we get 8 distinguished points on the circumference of the circle. And then we draw the front view. And then as per the problem statement, it is told that the entire lamina is inclined at an angle of 45 degrees with respect to the HP. So we get the front and the top views. And in the top view, we are going to consider it to be a ellipse by considering the two diameters, that is major diameter and minor diameter. So GC is the major diameter and AE is the minor diameter. So we use the ellipse by 3 point option to draw the top view of the circle. And now he tells that the diameter which is perpendicular to the diameter passing through the point on which it is resting is parallel to VP. So the diameter which is perpendicular is GC to the diameter AE which is passing through the point A on which it is resting. So you can see that the point A is towards the right hand side of the observer. And this diameter GC is made parallel to the VP. So we are going to consider this second position of the distorted circle in such a way that the major diameter of the ellipse is made parallel to the vertical plane, and then in the initial condition, since it is resting on one of its point A, we ensure that it is also touching the point A in the final position. So then we draw the top view of the ellipse and then the front view of the ellipse. So now we shall use the leader option to indicate the direction of the projection lines. These are all drawn downwards. These are all drawn upwards. With this, we complete the construction of the solution for the given problem statement. Thank you all for watching.